Hello, this is FlippedHarber for Physics. In this video, we're going to talk about acceleration. Our outline for this lesson is to talk about acceleration, average and instantaneous acceleration, the average acceleration equation, the difference between positive and negative acceleration and what that really means, and finally we'll talk about getting the acceleration from a velocity time graph. Now, acceleration is what we get when an object has changing velocity. And we're actually going to calculate the acceleration by calculating this change in velocity. One thing I want you to remember is that velocity has two components, speed as well as direction. A change in either one of those means that the object is accelerating. So try to look at it this way. If you're driving around in a car that has both a speedometer and a compass, usually up here in the mirror, to tell us speed and direction, if either one of those gauges is changing, the car and you inside it are accelerating. So if the speedometer is changing, you're speeding up, you're slowing down, that's acceleration. If the compass is changing, you're changing direction, so again, you're accelerating. We're going to be focusing on the changing in the speed type of acceleration for a little while. We'll get into the changing direction later in another chapter. Now, average and instantaneous acceleration, like average and instantaneous velocity, basically depend on how did we get the information. If we use an equation to calculate the acceleration, that's average acceleration. Whenever you use that equation to find acceleration, you're finding an average acceleration. Instantaneous acceleration is a little bit harder to come by. We can use a device to measure the acceleration. Those are called accelerometers. Or if you take enough math, you get up into calculus, we can actually use calculus to find an instantaneous acceleration. Obviously, we're not going to be doing that. We're really going to be focusing on finding average acceleration. Now, how do we find that average acceleration? Here's our equation. Acceleration, which by the way is a vector quantity, that's why the bar over the A, is equal to the change in velocity divided by the change in time. Now, whenever you're finding the change in something, you always go final minus initial. So we take our final velocity minus our initial velocity and divide it by our final time minus our initial time. Taking a look at the units here, velocity is typically in meters per second. Time is in seconds. So when we take meters per second divided by seconds, we get a new unit, our standard unit for acceleration, meters per second squared. Now this is our standard unit for acceleration. Not that we can't have other units, but this is the one that we deal with the most. A distance divided by a time squared. Alright, let's talk about positive and negative acceleration. Really, what I want you to focus on is don't use the word decelerate. It's got a connotation of slowing down. A negative acceleration does not always mean slowing down. If you mean the object is slowing down, just say slowing down. Or if you mean that the acceleration is negative, just say negative acceleration. Don't use the word decelerate, because what we're going to find out is a negative acceleration can actually mean the object speeding up. Let's try to go through some examples here. We have two race cars, both traveling in a positive direction. The car on the top starts with a small initial velocity. The car on the bottom is starting with a larger initial velocity. If we apply a positive acceleration, that is that it also points to the right, that's going to increase the top car's velocity. His final velocity is a bigger vector than his initial velocity was. Let's take a negative acceleration and apply it to the bottom car. So that's going to make his final velocity vector shorter than his initial velocity. So this guy is slowing down because of that negative acceleration. but it always doesn't work this way. Let's flip things around a little bit and look at it going the other way. So the top car has a negative velocity. When we apply a positive acceleration, this time in the negative direction, it's going to make his final velocity smaller than his initial velocity. If we apply a negative velocity, a negative acceleration, it's going to increase his negative velocity. His velocity vector is longer than it was before. So here, a negative acceleration caused the car to speed up. Now you probably wouldn't have looked at it that way before this lesson, but negative acceleration means that it's pointing to the left, typically, and that can actually make an object speed up. Don't ever use the word decelerate. Use the term slow down or a negative acceleration. Now let's talk about finding the acceleration from velocity time graphs. It's really just like when we found velocity from position time graphs. Velocity and position have the same relationship as acceleration and velocity. So really all we need to do is look at the slope of velocity time graphs in order to find acceleration. So let's take a look at some graphs from the book. I want to rank the 5 objects based on their acceleration. And I also want to make sure that I indicate any ties, that is, any objects that have the same acceleration. I want to note that they're equal. So what would be my lowest acceleration? I need to look at the slopes of these graphs. So what would have the lowest slope? Well, it's actually object C. Because it's a negative slope, it's a negative acceleration. So that's our only negative acceleration on this graph. So what comes after that? After our only negative acceleration, we have our zero accelerations. Objects A and E both have a zero acceleration. I know that it's zero because their slopes are zero. Now this does not mean that they're not moving. A horizontal line on the velocity time graph does not mean they're not moving. It means they're not accelerating. So after our negative acceleration, after our 2 zero accelerations, what comes next? Well, objects B and D. Which one has a bigger acceleration? Which one has a bigger slope? Well, they're actually equal. Objects B and D have very different velocities, but they have the same slope, so they have the same acceleration. Alright, that's it for this lesson. You've got your homework for this section. I think you've got a couple other videos to watch as well if you haven't gotten to it, so make sure you check your sheet. And I'll see you in class and I'll see you online.